In April, after months of silence, Voyager 1 finally spoke again from more than 15 billion miles away. And what it sent wasn't just routine data. It raised new, unexpected questions about what lies beyond the solar system. The responses it's offering are nothing like what scientists thought they'd see Voyager. One has reached the far boundary of the sun's protective bubble, known as the heliosphere. But what it's discovering out there is changing the way we understand interstellar space entirely. Once Voyager crossed the heliopause, it's the outer edge of that bubble it became the first human-made object to enter true interstellar space. After enduring a months-long blackout, the spacecraft has begun transmitting again. The data it's sending is challenging long-held assumptions about the space between stars. The interstellar medium Voyager is now exploring is revealing surprises that are shifting our grasp of the galaxy itself. Instruments aboard the craft are detecting phenomena no one predicted, evidence of a vast, dynamic, and strangely structured environment, far different from what existing models had suggested. This isn't just another report from deep space. It's the first time humanity is directly sampling what's outside the sun's reach. The truth is more astonishing than fiction. Something is different out there. The space Voyager is now moving through more than 15 billion miles from Earth. Doesn't match previous scientific expectations. Its instruments are showing that interstellar space is far from the cold, empty void once imagined. One of the earliest shocks came from the magnetometer readings. Voyager recorded an interstellar magnetic field sharply tilted compared to the sun's, while some misalignment was expected. This dramatic angle suggests Voyager may be entering a region of magnetic turbulence, possibly a place where galactic magnetic fields are bending, tangling, or reconnecting. These aren't minor variations they hint at, structures that could reshape our understanding of the galaxy on vast scales. Voyager has also detected sharp increases in plasma density, like pressure waves traveling through space. These aren't random. They may be signs that Voyager is moving through ancient shock fronts, left behind by exploding stars thousands of years ago. Even the idea of space being silent is being overturned. The plasma wave instrument is picking up continuous low-frequency oscillations. Space isn't silent, it hums. There's a constant subtle signal, a kind of whisper that fills the emptiness between stars. Imagine Voyager not floating in a vacuum, but navigating an invisible mist, sometimes warmer, sometimes thicker, that hum. It might be the weather. Of interstellar space, even more surprising is how organized the interstellar medium seems to be. Rather than drifting through a uniform sea of particles, Voyager's moving through well-defined zones, each with its own conditions, like passing through different climates across an ocean of stars. As it travels farther, Voyager is encountering strange new cosmic patterns, bursts of radiation, waves of pressure, sudden shifts in density. One of the most startling moments came just after it crossed the heliopause. Voyager registered a sharp increase in cosmic ray-Z energy particles, traveling near the speed of light, flung across the galaxy by supernova and black holes. The shift wasn't gradual. It happened almost instantly, like crossing an unseen border. This sudden spike reveals something profound. The sun's heliosphere is a far more effective shield than previously believed. Earth and everything inside, our solar system, exists within a kind of protective shell, guarded from the harsh radiation beyond. But the pattern of cosmic rays Voyager is detecting isn't uniform. The variations suggest the interstellar medium may contain natural radiation, channels like invisible highways guiding these particles across the galaxy. The data hints at a larger structure, perhaps gradients of pressure that shape how radiation flows across vast regions. Some scientists think Voyager may be entering a low-density void, a leftover from an ancient stellar explosion. If so, this isn't just local weather. These are remnants of cataclysmic events that reshaped our galactic neighborhood millions of years ago. In late 2023, Voyager went silent. After nearly 5 decades of loyal service from the edge of space, it stopped sending intelligible data. For months, its signals were distorted and unreadable. This wasn't a minor glitch, it was a crisis playing out 15 billion Miles from Earth, engineers at NASA trace the problem to a corrupted memory chip, likely damaged by a cosmic ray. In a twist of irony, the same high-energy particles Voyager has been studying for years had wounded the spacecraft. The solution was extraordinary. Engineers had to rewrite the code, reroute it through backup memory, and do it all remotely, using technology from the 1970s. The round-trip time for a signal? More than 22 hours? It was the space equivalent of performing brain surgery from across the solar system. And it worked. By April 2024, Voyager began transmitting basic telemetry against its vital signs. A month later, scientific instruments started to come back online. By June, all 4 remaining science tools were operational once more, each revealing new clues about the invisible environment surrounding us. What Voyager is detecting now isn't just data, it's a glimpse into the hidden framework of the galaxy. But this effort wasn't just about saving a spacecraft. Without the repair, we would have lost our only source of direct data from interstellar space. And now, Voyager is doing more than observing. It's helping build the first real map of the space between stars. Scientists are using its readings, magnetic field angles, cosmic ray flows, particle densities, to create 3D models of the galaxy's structure. This isn't guesswork anymore. These measurements are shaping a real chart of the interstellar environment. What Voyager is detecting voids, boundaries, dense zones, radiation corridors could one day help future spacecraft navigate safely or avoid dangerous regions. This mapping might even shape future missions that send humans beyond the solar system. The implications go deeper. Some researchers think the structures Voyager is charting twisting magnetic fields and varying particle flows could even influence star formation by channeling matter into dense pockets. Voyager isn't just surviving, it's quietly tracing the galaxy's invisible architecture in real time. Each transmission adds detail to this unfolding map, just as we begin planning missions to the outer planets and eventually beyond. What's becoming clear is that the space between stars is not an empty stretch. It's more like an ocean with currents, turbulence, and weather systems that are constantly changing. Since entering interstellar space, Voyager has passed through at least 2 distinct cloudlets, regions where the density of dust, gas, and plasma increases abruptly. These aren't visible clouds, but the instruments on board clearly detect these boundaries. Voyager's data shows structured plasma ripples like weather fronts moving through this space. These are not random disturbances. They're organized and defined. With characteristics that suggest vast underlying systems at work, scientists now believe that the Sun is currently moving through something called the local interstellar cloud, a dense region of space within a larger cavity known as the local bubble. That bubble is thought to have been carved out by ancient supernova. The changes in density Voyager is detecting could have ripple effects all the way back to Earth. As our solar system drifts through these regions, our exposure to cosmic radiation changes over time. It might even influence Earth's climate or biological evolution on a very long time scale. What Voyager is showing us is that the edge of the solar system isn't a clean cutoff. It's a tangled, shifting mix of plasma, magnetism, and radiation. The boundaries aren't fixed. They move and evolve as the Sun orbits the galaxy at over 450,000 miles per hour. Every new measurement refines our understanding. It's revealing that the galaxy around us is more textured, more active, and more interconnected than anyone imagined. Voyager's mission may wind down in a few years as its power supply fades. But its journey has only begun. The spacecraft will keep drifting silently through space long after we're gone, in about 40,000 years. Voyager 1 will pass within 1.6 light-years of a star called Gliese 445, a cosmic near-miss. But Voyager carries more than instruments. It carries a message, the golden record. Packed with sounds, music, greetings in 55 languages and 116 images, it's designed to last for over 1 billion years. Even if human civilization fades or transforms, this tiny archive will continue its Voyager story, preserved. No other human object will leave the heliosphere for decades, perhaps longer. Voyager is the furthest trace of us in the universe, a quiet ambassador that may outlast our entire species. So what has it truly found out there? Not aliens, no wormholes, no science fiction. What Voyager discovered is more unexpected and more real, hidden boundaries, powerful forces, and a galaxy that's alive with unseen structure. The transition out of the solar system isn't smooth. It's a turbulent, complex process. Magnetic fields don't align. Radiation levels shift sharply. Plasma waves ripple constantly. The most important insight may be this: Earth exists inside a rare shelter. The sun's bubble shields us from a much harsher universe. Our solar system is a haven in a cosmic storm. Voyager crossed the boundary, and what it found was more than we imagined. It's changing how we see our place in the galaxy. And it's not done yet. When Voyager 2 launched in 1977, it carried with it a golden recorder curated collection of human voices, music, and a diagrammatic map of Earth meant to serve as a symbolic greeting to the universe. At the time, no one could have imagined that this modest spacecraft, built with 1970s technology and possessing no more computing power than a basic pocket calculator, would one day become humanity's first eyewitness to a region that seems to defy all known laws of physics. Now, more than 12 billion miles from Earth, Voyager 2 has entered a realm where the very fabric of space appears to come undone. Here, plasma pulses erratically, magnetic fields twist and ripple like strands of silk, and subatomic particles behave as if guided by invisible forces. This isn't just raw data. It feels like a whisper from the edge of reality. What that whisper reveals could change everything we thought we understood. The boundary it crossed, once believed to be the outer shell of our sun's influence, is known as the heliopause. It was thought to be a soft, gradual transition where the solar wind gives way to the quiet calm of interstellar space. Yet when Voyager 2 moved past this expected limit, its instruments began registering anomalies of an epic scale. Rather than encountering a fading region of chaos, it found a place of structured, inexplicable tension. The magnetic fields, instead of weakening, grew stronger. The particles didn't decelerate. They moved in swirling, patterned motions that existing models couldn't predict. Most disturbingly, Voyager 2 recorded abrupt shifts in the direction of cosmic rays, as though they were being guided or, worse, repelled. It was as if the probe had stepped into a fog and collided with an unseen wall, one that moved, one that may have been watching. What came next challenged the foundation of astrophysics. The magnetic field around Voyager 2 surged. 2-3 times the expected strength, far more powerful than what Voyager 1 had experienced in the same general area. But the anomaly wasn't only about intensity, it was about direction. The magnetic field was oriented in sharp, unnatural angles, misaligned with what was anticipated based on galactic models. Some researchers proposed that Voyager 2 may have intersected a filament of galactic magnetism, a cosmic spine binding the galaxy together. Others speculated something more mysterious, a remnant from a long-dead star, or even the remnants of an artificial construct, a kind of forgotten signal, tower adrift in the void. All the while, this field enveloped Voyager 2 like a web pulsing with unseen intention. Plasma, the fourth state of matter, typically behaves predictably over interstellar distances, chaotic, hot, and sparse. But the plasma Voyager 2 encountered was none of those things. It was colder, denser, and disturbingly stable. Instead of drifting through it, the probe met resistance, like sailing through a cloud that fought back. Structured and patterned as though alive. Scientists began referring to this region as a liminal zone, a term borrowed from psychology because the plasma didn't fit any known category. It wasn't solar. It wasn't interstellar. It was something else entirely. And as Voyager moved further in, the plasma began reflecting signals back. These weren't random. They contained distortions suggesting eddies, folds even, a kind of architectural layering. The outer boundary of our solar system, it turned out, wasn't simply porous. It was layer-draped in a sheath of unknown energy, like skin enveloping a living cell. Then came the sounds, not audible to the human ear, but converted from low-frequency radio waves picked up by Voyager's instruments. These transmissions contained distorted hums, resonant harmonics, and pulsing rhythms unlike anything previously recorded. Some frequencies repeated like a heartbeat. Others sounded like an unanswered call. Scientists analyzed the waveforms. They discovered that these signals were not shifting at random. They changed over time in a pattern that suggested they were responding to something. Were they echoes of long-dead supernova? Gravitational tremors from deep galactic space? More chillingly, could they be evidence of interference from a force or structure that had noticed us? The notion that something could manipulate radio waves over billions of miles was once unthinkable, until Voyager 2 recorded exactly that. As the probe ventured further into interstellar space, it began to encounter an entirely new anomaly. Tightly packed curtain of high-energy particles only a few million kilometers wide. At first, scientists weren't alarmed. Cosmic rays are expected beyond the heliopause. But these rays were different. They traveled in synchronized parallel streams as if moving through guided channels. Even more unsettling, their density fluctuated in perfectly repeating intervals, too precise to be random. Simulations run at the Jet Propulsion Laboratory. JPL failed to reproduce the phenomenon. It appeared that Voyager 2 had crossed into a corridor where charged particles were being actively shaped. For the first time, scientists considered that this might not be a boundary at all, it might be a signal. Astrophysicists across multiple institutions began reviewing years of archived data, and patterns began to emerge not from a single signal or image, but from dozens of datasets. These patterns revealed a spiral progression, a logarithmic structure that kept recurring in particle arrangements, in plasma waveforms, even in the timing of magnetic field fluctuations. It was the golden ratio phi-n irrational number that shows up in everything from Nautilus shells to galaxies, but had never before been seen in particle data at the edge of the solar system. Neither the Hubble Space Telescope nor the Webb had planned for this. Only Voyager 2 at this exact location captured it. It was as if the universe had signed its name in a language only visible from a specific vantage point, detectable only by a spacecraft that had the patience to get there. Then, after more than 4 decades of relative silence, something extraordinary occurred. As Voyager 2 moved deeper into this particle-rich corridor, its orientation began to shift. Its position, typically stabilized by onboard gyroscopes and tiny thrusters, changed without any input from Earth. The change wasn't abrupt or chaotic, it was slow, deliberate, like a sailboat drifting on an unseen current. Initially thought to be a malfunction, further diagnostics showed no errors. Something external was affecting the probe's angular momentum. It was as if a weak, invisible, rotating mass to diffuse to detect, but massive enough to exert influence was gently twisting the spacecraft. Scientists dubbed this region the zone of rotational drift. Theories varied. A local gravitational eddy, the outskirts of a rotating cosmic structure, or even a propulsion wake left behind by something Voyager couldn't detect but might have. Briefly followed, and then came the most enigmatic discovery of all. A recent spike in Voyager 2's sensor logs recorded a high-energy anomaly, one that precisely matched the signature of its original launch. Pulse from 1977, the same frequency, the same waveform. But this signal didn't originate from behind. The probe came from ahead. Scientists triple-checked the data. Somehow, the echo of Voyager's own birth had returned to it, bent and reflected by something far beyond our comprehension. Was this a natural loop in spacetime, a signal bouncing through dimensional folds, or something even more profound? A response encoded in the very frequency we once used to declare our presence? The implications stunned the scientific world. If the probe's original signal had been reflected back by something ahead of it, then whatever lies beyond the boundary of our solar system is not only ancient, it is aware, and it is listening. Voyager 2 was never intended to make it this far. It wasn't designed to reach the edge of the solar system, let alone pass beyond it. Yet it did, powered only by the decay of radioactive elements and propelled by a human desire to explore. It reached a part of the cosmos where known laws seem to collapse and only questions remain. But perhaps the most profound discovery isn't the plasma, the magnetic anomalies, or the mysterious particle corridors. It's the realization that Voyager 2 didn't just travel through space, traveled through meaning itself. Because when patterns emerge from chaos, when light sings in sacred ratios, and when echoes return from the dark bearing the signature of our own voice, we are no longer mere observers. We are being acknowledged. We launched Voyager 2 to learn about the universe. But maybe, just maybe, the universe is using it to learn about us, and if something ancient, silent, and watchful lies just beyond our star's fading influence, then perhaps this discovery wasn't a mistake. Perhaps it was an invitation. If this challenges your perception of reality, if it makes you wonder what truly lies at the edge of everything we know, don't let Voyager 2's voice fade. Share this message. Follow the signals others overlook. The story didn't end at the edge. It started there. Share this with someone who still believes space is empty. And ask yourself, did Voyager 2 discover something unimaginable, or was it discovered?